Hey guys, it's S, and welcome back to another video. Now, I want to teach you guys a really cool math thing. Basically, it's called DeMoivre's Theorem. And basically, it involves a lot of stuff from complex numbers. So, we're going to define terms here. Basically, I'm going to write a bunch of numbers on the board, and you guys aren't going to go crazy over it. So, it basically says the nth root of z equals the nth root of r times the cosine of theta plus, not cosine theta, sorry. Cosine theta plus 2 pi h over n plus I sine theta plus 2 pi h over n. There we go. That's the whole formula. Now, z here just means a plus bi. Anybody who takes math knows that this is a complex number. So 3 is like a real number, right? And then 3i will be a normal number, an imaginary number. And this would just be a complex number. So z, for example, would be this. Now, you also have r here. Now, r is in reference to this real and imaginary plane. For anybody who's ever taken pre-algebra or algebra, it is literally just an xy graph, but x is real and y is imaginary. It's not that complex of a graph, even though people make it sound cool. Now, z is normally in reference to some point like here in the middle of the graph, where it's both real and imaginary at the same time, and normally you want to know the distance of this thing to find the square root. Now, this is kind of what this formula helps you with. It helps you find the nth root of some number. Now, there's a theorem that says that any amount of roots, if something is raised, if a variable is raised to the nth power, then it has to have that many roots. So, for example, x to the third equals 8. This means x has to have 3 answers to it since it's raised to the third power. Now, if you know how to factor it, you'd know it's just x minus 2. This is just a difference of cubes because it's x to the cube minus 8. So it's x minus 2, x squared plus, I think it's 2x plus 4. Now, basically, a difference of cubes means you match the sign here, switch the sign for this one, and it's a plus here. It's a math thing. It works. Just know that it works. Now, this means that x has to equal 2 here, because this equals 0, so x has to equal 2 here. Or x here, you have to factor it out, and here you can use the quadratic formula, which is b over 2a plus or minus the square root of b squared minus 4ac over 2a, and you would get 2 over 2 plus or minus the square root of 4 minus 16 over 2, and then that would just be 1 plus or minus the square root of 12 over 2, and that's just 1 plus or minus 2 square root of 3 over 2, because the square root of 12 is just the square root of 3 times the square root of 4, and the square root of 4 is just 2. And then the 2's here cancel, so it's just 1 plus or minus the square root of 3. Now, those are the other two answers. So we have 1 and then 2, 3, because this is a plus or minus. That's all that x can equal here. Now, DeMoivre's theorem makes it so much easier, because let's say we had, I don't know, x to the 5th equals 64i. How do you find 5 roots of this really big number? Now, most of you guys are going to say one of them, which might be like 2 or something. But here, it's an imaginary number because it's on the imaginary plane, so it's like somewhere here. Anyway, that's what DeMoivre's for. Now, as I said, z's complex. R is the distance away from the center of the circle, so it's kind of like the radius of the circle. Theta is the angle which is it's at. So at over here, let's say the angle would be 0. Well, we're measuring this in radians, so it would be 0, pi over 2, pi 3 pi over 2, and this would also be 2 pi. Now, this 0/2 pi, it could be either. This 0/2 pi is like a theta. It's that angle. It's how many radians there are. There's 0 radians here. There's pi over 2 here. Pi 3 pi over 2. That's what's going to be our theta. Now, we have 2 plus 2 pi here, so a full revolution, as you can see, and then h. And now h here is just basically 0, 1, 2, and all the way to n minus 1. So it is basically, you're going to do this how many times we have the root. Now, we're going to put this reference problem on the top, which is x to the 5th equals 64i. Now, if that's the case, that means x to the 5th minus 64i has to equal 0. Now, if that's the case, that means our angle is probably going to be somewhere over here. Now, the r is just going to be how long that is. And h is going to go all the way. In this case, it's going to be 0, 1, 2, 3, 4, and 5. Now, this is going to be multiplied by this 2 pi h over here. And then it's going to be divided by the amount of roots. And then plus I sine. So, we're going to start the calculation right now. Basically, I'm gonna keep this on the board because we are definitely going to reference this a lot. Now, the nth root of z, which is this complex number right here, is r. So, we know the first root is x, x equals 2, right? So, the nth root of 64i here would, the root of the function would be the radius. Now, that's 2. We know it's 2 because 2 times 5 is 64. Now, we need that as a basis to calculate all our other ones. Now, we have cosine of theta here. Now, theta is up here, so it is pi over 2. Since there's no x or real number, it's going to be up here, and we're going to start at pi over 2. And it's going to be plus this 2 pi h. And it's going to be pi over 2, and then times the n, which is 5 here. Never mind, I don't want to do that. I don't want to make it complicated. We are going to do something more simple, mainly because I don't know what the pi of that is. We're probably just going to do x to the 3rd equals 8i. You know what? We'll do that. Now, it still starts here, and we still have 2 here, but instead we have cosine of, we have pi over 2, of course, and then plus 2 pi times 0 over 3 plus I sine pi over 2 plus 2 pi 0, and all of that equals over 3. Now, this 2 pi 0 just cancels out for both these terms. Cosine of pi over 2 here, we're looking at this x-axis, it's going to end up here, which is 0, right? So this whole thing is just 0, and 0 over 3 is just 0. I'm going to put the values down here so we remember. Now, sine of pi over 2 is 1, because in reference to the y-axis, it's over here. Now, this means that it's 1, and it's 1 over 3, so it's 1/3. Now, that's actually not how you do it. My bad. This whole expression is in sign, just for you to remember. This whole expression is in sign. Now, it's pi over 2 over 3, so it is pi over 6, actually. This is pi over 6. We're just going to edit out the mistakes, guys. Okay. So, this will be pi over 6 plus 2 pi times 0. That cancels. And it would just be cosine pi over 6. So, instead of being up here, it's actually like, let's say right here. Now, because it's over this n, that means it's going to like chop up the circle into that many pieces. So we're going to have like 8 dots around this circle to find all our things. Now, the cosine of pi over 6 is, since here it's longer, I know this isn't a good representation, but pi over 6 like is around here, and then 2 pi over 6 or pi over 3 is around there. Anyway, since it's longer, we can say it's root 3 over 2, because root 3 is bigger than 1. So always remember, this is a good rule of thumb, if you're dealing with 30, 60, 90 triangles, 30 triangles, I don't know why I put it there. Let's just draw this real quick. If there was a 30-degree angle here, cosine is longer than sine, okay? That means that it's root 3 over 2 over here, and it's 1/2 over here. If it's 60 for this angle, then it's 1/2 down here and root 3 over 2 over here. This means that you can easily calculate what the cosine and sine is for these numbers. So just think of cosine and sine here as like x, y, blah, blah, blah. Now, this length here is root 3 over 2. So we're going to put 2 times root 3 over 2 plus I times whatever sine is. Now, sine in this case, as I just said, is 1/2. So this becomes 1/2. And then you multiply that by 2, so it is root 3 plus I. Because 2 over 1/2 is 1, I times 1 is I, root 3 over I. That's our first answer. And we are going to do this again. Now, our first answer is, as you know, root 3 plus I, right? Now, the next one, we do cosine theta plus 2 pi 1 is times 1 all over n plus I sine, or not over n, over 3. We know it's 3 now. Now theta here is still going to be the same thing. It's still going to be pi over 2 because it has that I, which means it's only up here. And then it will be pi over 2 plus 2 pi over 3. Now, you're adding 2 pi to pi over 2, so I like to turn this into decimal form so I know what I'm doing. This becomes 4 pi over 2, 4 pi over 2. And then this becomes 5 pi over 2 over 3 for both of these. So it's just 5 pi over 6. So this whole number turns into 5 pi over 6. This also becomes 5 pi over 6. And now we can start figuring out what it is. Now, over here is 5 pi over 6. Now, the reason why is because to get a full pi, you need 6 pi over 6, right? So 5 pi over 6 is slightly less. So we know it's in the second quadrant, and we know that it is a 30-degree angle here because of what it is. Now, if it's pi over 6, it's a 30-degree angle. If it's pi over 3, it's a 60-degree angle. So pi over 6 would be a 30-degree angle. If it was 2 pi over 6, it would be a 60-degree angle here, because it can simplify to just pi over 3. This is a good rule of thumb if any of you guys are taking trigonometry and you want to easily figure out stuff when they ask you to graph it. Now, since we know that it's 30 here, x is negative, we got to keep that in mind, so it will be negative of whatever this is. In this case, it's also root 3 over 2. This is, and then this is 1/2, and y is positive here because it's still up here. It's quadrant 2. Now, 2 times root 3 over 2 is minus root 3, and then it's plus I, because there's this I here. Now, our second answer is negative root 3 plus I. Now, what is our third answer? I wonder what it's going to be. You could probably guess what it is. It has something to do with it too, most likely. Now, we have cosine pi over 2, of course. Can't forget that pi over 2. Plus 2 pi times 2 over 3 plus I sine pi over 2 plus 2 pi times 2 all over 3. Now, we're going to put the same thing over here, so over 2, and then you do times 2 again, because we need to offset it. Now, 2 times 2 times 2 is just 8 pi. 8 pi plus pi is 9 pi. And then everything's over 2, but it's also going to be over 3, so we're going to say 9 pi over 6, which is 3 pi over 2 for all of these. So this is also 3 pi over 2. We're just going to put this whole thing as 3 pi over 2. Over 2, yep. And then we're going to do the same thing for I sine over here. 3 pi over 2. Now 3 pi over 2 is down here. It's this point right here. And because it is this point, this means that the cosine here is 0. So we can just cancel that out, and that's 0. And the sine over here is just 1. I mean negative 1, because it is down here. So this is negative, this is positive, this is negative, this is positive. And because it's negative and on the line, we're using the unit circle here. And because it's a unit circle, the radius is always 1, because we already have the radius right here. So we're using the unit circle as a reference. This is then negative 1. So then this would just be negative 1i, or negative I for people. And then you multiply 2 by negative I, it would be negative 2i as that final answer, negative 2i. Now, some of you might be saying, what if it's false? What if it doesn't work? Now, I'm going to fact check these answers just for you. Now, root 3 plus I times root 3 plus I times root 3 plus I. Now, I don't feel like manually factoring this, so I'm just going to do the box method where I put the answers to the side. It's basically like a Punnett square for those who take biology, and you just multiply the numbers and whatever the multiplication equals, you just put it in that corresponding box. Now root 3 times root 3 is 3, root 3 times I is root 3i, and root 3 times I is root 3i, and I times I is negative 1, because the definition of I is that it's the square root of negative 1. Now, that means it is 3 plus 2 root 3i minus 1, and then you have to multiply that by root 3 plus I. Now, I'm going to say something here. You could have easily just figured out, because this is just a plus b squared, which is just a squared plus 2ab plus b squared, to help my algebra friends out. But I wanted to do the factor method so people know how to do it. Now, we're going to multiply these numbers by root 3i. And I'm going to use the same box method, except it's going to be a 3 by 2. So we're going to get a lot of values here. So now 3 times root 3 is 3 root 3. 3 times 2 root 3i is 6i, because this 3 times root 3 equals 6. 3. 2 times 3 equals 6. And then you have I. 3 times I is 3i. Root 3 times 2 root 3i is... I times 2 root 3i is negative 2 root 3, because it's I times I, which is negative 1. Negative 1 times root 3 is negative root 3. I times negative 1 is negative I. Now, this is going to be 3 root 3 minus, this gives you 3 root 3, and then plus 6i, and then you get plus 3i minus I. So these cancel, obviously, and then this would become 9i, and then this would become minus I, and that's just 8i, which is like our previous equation. Now, we're going to fact check the other one. Now another answer we had was negative root 3 plus I. This time I'm going to use the formula that I just showed you guys. So negative 3 squared is 3, because it's negative times a negative, which is positive, and then the roots times each other equals the number inside. So it's 3 plus, well, actually, in this case, it's minus, because a minus b squared equals a squared minus 2ab plus b squared. Now, that means that it is minus 2 times root 3 times I, and then it's plus, or actually it's minus 1 here. It's minus 1 because b squared I times I is negative 1, so it's that. And then I'm going to do it by negative root 3I, and we're going to do the big box. And now we're going to have 3 times negative root 3, which is negative 3 root 3. And then this negative root 3 times negative 2 root 3i, it's just going to be 6i again, because the negatives cancel, and root 3 times root 3 is 3, 3 times 6, 3 times 2 is 6, and then 6 times I is 6i. And then we have here negative 3 times negative 1, and that's just root 3. And then you have I times 3, which is just 3i. And then minus 2 root 3i times I is just 2 root 3, because the negative gets canceled with the I times I, which equals a negative. Negative times a negative equals positive. And then you have I times negative 1, which is negative I again. And now we see that these just cancel out here. And then you have 3 plus 6i, which is just 9i minus I, which gives you 8i. So these two solutions are correct. Now we're going to go to the final one, which is negative 2i. Negative 2i times negative 2i. If we multiply this out, this would be negative 1 times negative 1 times negative 1, right? Because those are the three minuses, and then you have 2 times 2 times 2, and then you have I times I times I. Now, this just becomes negative 1 in the end. This becomes 8 in the end, and this becomes negative I in the end. Negative 1 times negative I is just I, and then you have 8I. And that is how DeMoivre's theorem works. See you guys in the next video.